Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In a previous video, we have understood the photodegradation of the polymers, and we have seen how these ultraviolet rays coming out of the sun radiation can affect different polymers. We can observe this photodegradation of the polymer by its physical change of the polymers. You must have noticed that your white shirt, after usage of some long time, it turns into the yellowish. So that thing represents this photodegradation of the polymer. And we have also seen different plastic material and the transparent material such as your mobile case also turns out into the yellowish color. So all this combinedly known as the photodegradation of the polymers. So is there any method by which we can reduce this photodegradation, or we can actually prevent the photodegradation of different polymers? Well, of course, there are the substances which are called as the stabilizer, or we can say photostabilizer, which are used to prevent our polymer from photodegradation. So as you can see here on the screen that the photostabilizer are kind of a compound that protect our polymer from photodegradation effect of the light at the considerable extent. So the photostabilizer are nothing but a special kind of a substance which actually protects our polymer from ultraviolet rays. There are different types of the photostabilizers. As you can see here on the screen that there are some examples 2,4 hydroxyl benzophenol, which is generally known as the uvinol 400. Then there is 2-hydroxide, 4-methoxyl benzophenol, and lastly we have DOBP. So all are these the photostabilizer which are actually used to protect our polymer from harmful ultraviolet rays. So let's see what is the actual function of these photostabilizers. As you can see here, the function of the stabilizer is to absorb all the UV radiation coming out of the sun and to dissipate the energy and thus absorb to the environment in some harmful manner. So this photostabilizer actually absorb all the radiation, that is ultraviolet radiation, coming out of the sun and convert it into the heat energy. And then later they dissipate this heat energy into the environment in harmless manner. So these photostabilizer are very important compound when we have to consider such plastic material or the transparent material. It basically acts as the filter, and it do not allow the ultraviolet radiation to attack on the polymer molecule. So we can say that this photostabilizer provide kind of a shield to the polymer, and hence this polymer is being protected from harmful UV radiation of the sun, and we can actually reduce the photodegradation of our polymers. Hence, this photostabilizer find their large application in the polymer industries. So, this was the function of the photostabilizers. Now, let's understand some of the example of the photostabilizer. And let's see what is actually happening on the molecular level when this photostabilizer absorb the UV radiation. As you can see here on the screen that stabilizer usually are the molecules with aromatic rings having hydroxyl group and ketone group. One thing in a previous slide you must have been noticed that all the examples of the photostabilizer are being on the benzene ring, and they have one common compound as the hydroxyl. So the photostabilizer are generally containing one hydroxyl group, that is your OH group, and either they can also contain ketone, that is your C double bond O group. So combinedly these things are being known as the photostabilizer. Let's understand one example of this photostabilizer. As you can see here on the image that this is the substitute form of the photostabilizer, in which you can see that this is the one benzene ring and this one is the another benzene ring. On the one side we have the hydroxyl group like this, and both the rings are being connected with the one ketone group. So this is the most useful form of the photostabilizer, right? And here you can see that one more example of the photostabilizer. Here it was having OCH3 and OCH3 on the both side of the benzene ring, while in this particular example it has OR group. You can see here we have one hydroxyl group here and ketone group as well. So combinedly both the thing is being known as the photostabilizer, and it is being used to protect our polymer from the photo degradation of the polymers. Now here you can see that most of the stabilizer have hydroxyl and ketone group in their ortho position. One more thing you must have been noticed that, let me just take a pen here. Always this hydroxyl group, particularly this one, is being connected with the ortho position of the benzene ring. As you can see here, this particular point is the ortho. If we consider this as the one position, then this one is your ortho, right? So hydroxyl group is being always connected with the ortho position. Here you can also observe that if this is the first position, then this one is the ortho position in which this hydroxyl group is being connected. So this hydroxyl and ketone group are generally connected on the ortho position of the benzene ring, which basically encourage the formation of the hydrogen bond. So this is the reason why this hydroxyl group is always being connected on the ortho position, because this ortho position always encourage the bond of hydrogen, right? So this hydrogen bond can easily made up with the stabilizer. So when the stabilizer will absorb energy or UV radiation, this hydrogen bond will be formed. So now let's understand what actually happens when this UV radiation fall on the photostabilizer and how it will protect our polymer from the photo degradation process. As you can see here on the screen that stabilizer absorb most of the light and subsequently convert into the heat and by the reversible reaction. So as you can see here, this is the reversible reaction is taking place when our stabilizer absorb ultraviolet rays. As we have here taken the example of the previous slide of the stabilizer, as you can see here, it has OH group on its ortho position. Previously it was shown at here, but here we can also be represented as the ortho group, right? So this is the hydroxyl group which is being connected on the ortho position of the carbon atom, of the benzene atom. Now on the application of the ultraviolet rays, this particular structure of the stabilizer will convert it, right? So this is the normal structure of the photostabilizer, and when it will absorb heat energy, or we can say it will absorb ultraviolet radiation, it will convert it into the structure like this. As you can see here, this hydrogen bond from this particular point, let me just take a pen here. This hydrogen bond from particularly this group will broke up, and this free radical will be shared by this carbon atom here, right? So this carbon atom will now make double bond like this. You can see here it will form double bond with the carbon, and one hydrogen will link with this oxygen atom as well. So this particular pi bond will break out and it will make one hydrogen bond in this way here, right? This is I have represented in this way. So this is what actually happens when this ultraviolet radiation fall on the stabilizer. The double bond between ketone group breaks up and one hydrogen is being liberated off, and new double bond is being formed between carbon-carbon bond like this. As you can see here, this is the double bond which has formed because of the UV radiation, and one hydrogen is being linked with the oxygen group. So this is the hydrogen bond structure which is being formed after the UV radiation. So if we extract heat energy from this particular structure, it will reform this normal structure of the photostabilizer like this. So now let's understand further this reversible reaction in much more detail. As you can see here, if A is represented by the stabilizer and the hydrogen bond structure is being represented by B, right? So let's just suppose this is your A here. Here, this is your A and this is your B. So this overall chemical reaction can be represented by this form. A gives B in the presence of the ultraviolet rays, while B gives A plus heat energy, right? So if we extract heat or we remove it from the B structure, then it will again reform the normal structure of the photostabilizer. So we can recover our photostabilizer as per our requirements. This absorption of energy and dissipation of heat will take place even at the low concentration of the stabilizer, and it will protect our polymer from harmful effect of the ultraviolet rays. So if our stabilizer is being present in a very dilute proportion, then it will also protect our polymer, as their absorption of heat energy or ultraviolet rays has nothing to do with the concentration. So you can see here the absorption of energy and dissipation of heat energy will be always there even if the concentration of the stabilizer is very small. And it will always protect our polymer from the photo degradation process. Right? There are some more examples of the photo stabilizer as well. So now let's understand them as well. As you can see here, there are some stabilizers such as 2-hydroxyl benzotriazole, which do not contain ketone but still capable of forming hydrogen bond structure. So this is not always required that your photostabilizer should contain ketone and hydroxyl group. There are some exceptional cases in which this ketone and even hydroxyl group is also being not present. But they act as the photostabilizer and they are being capable of absorbing ultraviolet rays and protect our polymer from the photodegradation process. And here you can see that the example of such molecule. This is the chemical structure of the 2-hydroxyl benzoyl triazole, which actually make the hydrogen bond on the application of the ultraviolet waves and protect our polymer from the photodegradation. So this was the all about the photostabilizer, right? We have understand the photostabilizer as the compound or a substance which actually protect our polymer from the photodegradation process, and its main function is to absorb all the ultraviolet radiation coming out of the sun and dissipate, or we can say convert this ultraviolet radiation into the heat energy, and later it dissipate this heat energy into the environment in harmless manner. So this was the all about the photostabilizer, right? We have also seen that this photostabilizer commonly contain one hydroxyl group and one ketone group. And we have also seen what actually happens when the ultraviolet rays comes in a contact with the photostabilizer and how its structure changes from the normal structure to the hydrogen bond structure. And later we have also understand there are some exceptional cases which act as the photostabilizer but do not contain any ketone or the hydroxyl group, right? In an upcoming video, we will understand the different properties of the photostabilizer and we will discuss the last topic of the degradation of the polymer, and that is biodegradation of the polymer. Till then, keep watching, keep learning. Thank you.